This is Mrs. Haase showing you how to solve a system of linear equations using elimination. This is also from lesson 3.2, however this is example 4. We want to stack up our linear equations so that the x's, the y's, the equal sign, and the constant at the end are all lined up. As you can see, mine already is. However, our goal is to cancel out either the x's or the y's. They must have the same number, and one must be positive, one must be negative. In this equation, none of that is true for us. The x's do not match, although one is a positive and one is a negative. The y's do not match, and both are positives. So I look to see which one is the easiest to make match. And I know that if I look at my y values here, I can multiply the bottom equation by 3, and that will make the y's be the same value. However, I want to make them opposites. So I'm going to multiply the bottom equation by a negative 3. If I multiply through on the bottom, remember I have to kind of like distribute. Remember to go all the way to the end, so everybody gets multiplied by negative 3. And negative 3 times negative 7 is positive 21x. Negative 3 times positive 2y is a negative 6y. And a negative 3 times a positive 31 is a negative 93. Now I did not change the top equation at all, so I'm simply going to bring it over and write it on top so that my equations are still stacked up. And now I notice that I have a positive and a negative 6y, so they will cancel out immediately. So I'm going to cross them out, and then I'm going to combine the leftovers. 10x plus 21x is 31x equals 0 minus 93 is negative 93. To get the x alone, I'm going to divide by 31 on both sides. On the left side, 31 divided by 31 is 1, so we cancel it out. On the right side, negative 93 divided by 31 is negative 3. That means our x value is negative 3. Now I need my y value, so I go back to the beginning and I get to choose either of the equations. I actually could use this third one that I created, but the numbers are very large and I don't want to deal with big numbers. So I'm going to go back to the top equation, 10x plus 6y equals 0, and I'm going to plug in my value for x. So 10 times negative 3 plus 6y equals 0. 10 times negative 3 is negative 30 plus 6y equals 0. I'm going to add 30 to both sides to try to get my y by itself. $30 minus 30 is going to cross out, bring down 6y. 0 plus 30 is 30. Divide on both sides by 6 to get y alone. And we find out 30 divided by 6 is 5. That means y equals 5. So our answer, if we put it together, is negative 3, comma, 5 in parentheses, because this represents a point. Again, this is one solution, which means the graphs of the lines would cross one time, and they would cross at negative 3, 5.